Following on from the previous video, we were trying to find out the limit of our sequence, capital L. So from here we would take the natural log of both sides, that will then give us this, and then here you've got infinity times 0, then so here you've got a product of two things. We would rewrite it as a quotient, as one thing divided by another. So now let's try and evaluate the limit of this. So as n tends towards infinity, this thing here is going to be 0, and then as n tends towards infinity, this thing here is going to be 0. So here you've got 0 over 0 as is an indeterminate form. So we would apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this, that will then give us this, and then differentiate this, that will then give us this. So by the way, if you differentiate this, imagine this as being this as being a bubble here. So natural log of the bubble here. So when you differentiate this, it will be 1 over the bubble times the derivative of the bubble itself. That will then give you this thing here, and then it's blah 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 here. If you differentiate this, it will then give you this thing here. So it will be blah blah blah. That will then give you this. So the point is that when you differentiate this, it will give you this. The point is that when you differentiate it, it will give you this. So this is exactly the same as this. Okay, so differentiate this, that will then give you this. Differentiate this, that will then give you this. So now tidy this up. Here you've got one thing divided by another. So imagine it as, well, imagine it as this fraction here, which is this bit here, multiplying with the reciprocal of this, which will be this. So now it's top times top, bottom times bottom. That will then give you this. So now find the limit as n tends towards infinity. Well, if you look at this, as n tends towards infinity, there are lots of ways of doing this. Here you've got one bubble divided by this thing here. As n tends towards infinity, you can imagine this bubble as being 2 to the n squared, and then this thing here, as n gets very big, you're taking away a tiny amount. That's next to nothing. So you can just imagine it as n squared. So now you can divide top and bottom by n squared. By the way, there are lots of ways of doing this. You can divide top and bottom by n squared. So divide this by n squared, divide this by n squared. There are lots of ways of doing this, but you can just imagine this. As n gets very big, this is gonna stay the same, and this thing here, well, this bubble here is just going to become n squared as n gets very big, because you can pretty much ignore this it's going to be negligible, this one here. So you can just imagine it as this, and then this will basically, the limit will be 2. So remember, remember right from the start, so the natural log here, natural log of what we want to know, the limit equals 2, because right from the start we we wanted to know the limit here. This is what we want to know. So we would take the natural log of both sides. That will then give us this. So here, this is natural log of capital L. This here will be natural log of capital L, natural log of capital L, and so on. Natural log and so on. So down here you will get the natural log of capital L equals 2. So now we want to know our limit here. We want to know capital L. So E equally to both sides. So that will then give you this, and then these two, in a way, they kill off each other, giving you your limit. So your limit is E squared. So you can say our sequence converges to E squared. Okay. So yeah.